Video we are going to see what are F block elements, why F block elements are called inner transition elements, write the electronic configuration of lanthanides and actinides, write about oxidation state of lanthanides and actinides. So for these questions we are going to see answers. In periodic table, at the bottom of the periodic table, there are two inner transition series present called F block elements. The first one lanthanides, second one actinides. Lanthanide series called 4 F block elements as they contain incompletely filled F orbitals. Here the actinides are called 5 F block elements as they contain incompletely filled 5 F orbital. Here the lanthanide starts with lanthanum and ends with lutetium. Lanthanum 4 of 0, the electrons are subsequently filled in each element, ends with lutetium of 4 of 14. The half-filled configuration gadolinium is 4 of 7. Here the actinium starts with the actinide starts with the actinium 5 of 0 and ends with the lawrencium 5 of 14. Here actinium 5 of 0 and lawrencium 5 of 14. And curium, the half-filled configuration 5 of 7. So why these elements are called F block elements are as they contain incompletely filled F orbital they called F block elements. The lawrencium 4 of 0 and actinium 5 of 0, even though they grouped along with F block elements as the properties are similar to other F block elements. They are also called as rare earth elements as they found rare in abundant, also called as rare earth elements. In lanthanides, the common electronic configuration with 6s2 orbital and the variable electron occupancy in 4f and 5d subshells. Similarly, in the case of actinides, the common electronic configuration with 7s2 and the variable electron occupancy in 5f and 6d subshells. The general electronic configuration of lanthanides. As it resembles xenon configuration, the configuration is 4 of 1 to 14, 5d 0 to 1 and 6s2 is the common electronic configuration of lanthanides. Here the lanthanum contains 0 electron in the 4f orbital and it contains 1 electron in the 5d1 and 6s2. Here the starting element. Here the gadolinium electronic configuration is half-filled configuration xenon 4 of 7, 5d1 and 6s2. And lutetium fully filled stable configuration xenon 4 of 14, 5d1, 6s2. And here before gadolinium, europium is present. Actually its configuration is 4 of 6. In order to attain the extra stability, here the configuration changed to 4 of 7, 6s2. And similarly, yttrium present before lutetium, the actual configuration is 4 of 13. To attain the fully filled stable configuration, the configuration changed to 4 of 14. Like that of lanthanides, the common electronic configuration of actinide is radon 5 of 1 to 14, 60, 0, 2 and 7s2. So the actinium, the first element present in the actinide series, possesses 0 electron in the 5f orbital and 6d1, 7s2. And curium, the half-filled configuration 5f7, 6d1, 7s2. The lawrencium, the last element fully filled stable configuration 5f14, 6d1, 7s2. Oxidation state of lanthanide. The common oxidation state is +3. It is found to be more stable according to its electronic configuration. For 5d1 and 6s2 involved in bonding means the stable oxidation state will be +3. It also exhibits +2 and +4 oxidation state but comparatively plus 3 oxidation state is found to be more stable. And another one, gadolinium and lutetium. Gadolinium is the middle element present with 4 of 7 configuration, 4 of 7 configuration, and lutetium is the last element with 4 of 14 configuration. Here the gadolinium 3 plus and lutetium 3 plus is found to be more stable. Gadolinium 3 plus ion and lutetium 3 plus ion is found to be more stable. Here gadolinium configuration is 4s7 5d1 6s2. In the 3 plus oxidation state, it will get the stable 4s7 configuration. So the 4 of 7 half filled stable configuration. So gadolinium 3 plus ion is found to be more stable. The gadolinium 3 plus oxidation state, here the gadolinium attains 4 of 7 half filled stable configuration. Thereby gadolinium 3 plus ion is found to be more stable. Similarly, lutetium 3 plus, the 3 plus configuration is found to be more stable, or ion is found to be more stable. In the case of lutetium, if 2 plus 1 3 electrons gone involved in the bond formation, it will get lutetium 3 plus. After the loss of 3 electrons, it will get the fully filled 4 of 14 configuration. It is found to be more stable. Fully filled configuration is more stable. So lutetium 3 plus ion is more stable. So gadolinium 3 plus and lutetium 3 plus. Gadolinium 3 plus half filled stable configuration 4 of 7. Lutetium 3 plus fully filled stable configuration. So they are found to be more stable. In lanthanides, urium and ytterbium, the plus 4 oxidation state is found to be more stable as it previous to the half filled and fully filled stable configuration. And next one is oxidation state of actinides. Like that of lanthanides, in the actinides also the plus 3 oxidation state is found to be stable. Even though plus 4 is present, plus 3 is considered to be found to be more stable. And also it actinides exhibit plus 2, plus 4, plus 5, plus 6, plus 7 oxidation state. Here the thorium with plus 2 oxidation state and neptunium, plutonium with plus 7 oxidation state. Here the plus 2 oxidation state, plus 4 oxidation state, the fewer number of oxidation state found to be more ionic, and here the plus 7 oxidation state, higher oxidation states are found to be covalent.